Okay, so this is a video for some of the user groups and a couple other people that asked me some questions. I'm not an expert on how Nexus does their RVs, but I'll show you what we have found and what we spent. We spent $8,000 fixing this. Not all of it was electrical, but a big majority of it. Most of it, a lot of it was tires, 5 new tires, because 3 of them were flat when we bought it, and they took care of those 3 painfully, but they took care of them. And then the other 2 was because of no alignment on it. So, so where to start? Boy, this is a little bit dirty here. Okay, so yeah, I got a whole. I don't know how all this stuff got in here. I gotta clean this area up. So this is my inverter, and this is an Ames inverter. It has a battery charger in it, and it has a bypass in it. You'll see at the back I've got a wiring harness that goes in and comes out. That's my AC in, my AC out. So the original inverter, the original install of this unit, first of all, they didn't know what they were doing, only had AC going in. Okay, so the AC was coming in, AC out. They only had AC going out. So the AC coming out was going to the distribution panel, and they weren't using any of the features of this. So I'm going to tell you also on this side, the battery cables, you'll see how thick these ones are. That is pretty thick. So it's not about amperage for these batteries. It's about voltage drop. So the way an inverter works is that 12 volts will get stepped down, negative, and it'll be stepped up, positive, and down, negative. Probably, I don't know, 20 times in each direction. I'm guessing, but a lot of different times in each direction. So if you start out with a lower voltage, you'll end up with a lower voltage AC. So it's artificially created. So the DC is dropped down in steps, and is pushed up in steps. So in here there is a timing circuit that basically, when I used to work on inverter legs for basically the inverter legs I used to work on were bigger than this whole RV put together, but they had a SCRs, they're silicon controlled rectifiers. They had a gating that would turn them on and off in a certain time, and you're going to create a modified sine wave. And then the difference between a true sine wave and a modified sine wave is just filtering at the end. So this guy here was put so far away from the batteries and in combination of not having the right battery cables, that the voltage drop before the DC got into here to create that AC, the voltage drop was so low, so much that when it created that, the AC was very, very low. So you want to be 120, 115 to 120 volts, and if most inverters, if it knows that it's starting out with a lower voltage, DC voltage, it just won't. It'll turn itself off to protect your equipment. So when your batteries are low, or this thing is too far from your batteries, it will turn itself off. Or if it's too far from your batteries, and when your batteries are at a certain level, a higher level of charge, once it gets down to a little bit lower level, because it's so far away, it will turn itself off. So what you want is, you want this as close to the batteries as possible, as humanly possible, with the battery cables as thick as possible for the lower voltage drops. That's a must. I don't care what inverter you have. The Magnum inverters, I don't know if they have a charger in here or whether they have a bypass switch in here. Mine has both. So the AC coming in comes in from the transfer switch under the bed. The generator and the shore power comes into that transfer switch, goes into this unit, and then when there is no AC, it senses there's no AC, pulls from the battery, and then it goes out the other side. So when it senses there's AC, it just transfers it. This thing will charge. You'll see there's a charge light here. So everything is charging right now. Another thing we found is, you'll see that battery disconnect. The battery disconnect that they had did not actually disconnect the battery. So it wasn't connected to the battery. The only way you know that the thing's disconnected is if this is actually on one of the legs of the battery directly, and nothing else is in its way. So they're disconnecting inside. I don't even know. They just threw it in there, so it wasn't disconnected. So that's that. Okay, so here's my battery bay. It's custom, so not all the I don't think they will have this in everything, in all the Nexuses. But this is my battery bay. It's got 4 6-volt batteries, 1, 2, and then there's, I don't know if you could tell, but there's 2 back there. So 3, 4. So these 4, they're 220, 225 each amp hours. And like all lead acid, even though these are AGM, all lead acid, you don't want to go too far below 50%. AGM can go, 6 volts can go a little bit lower, but you really don't want to. This is my shunt meter. It is not connected. My solar doesn't go through it, but everything else does. And I installed this switch here to turn it on and off. You'll see inside. So because I just wanted to have a battery monitor. That's better than the one we have. This was $29 on Amazon. It was really pretty easy. It's super easy to hook up. So one of the problems on this, again, these things, these batteries that they put in were did not have the thickness. You want 2 gauge 1/0 thickness. You want pretty thick cables here. So there's not much to say about these. These behind this wall here, there is I put right here on all the units. There's a wall back here, and I don't know if you can see it, but on this side, over towards the driver's side, there's a wall here with a lot of relay switches in it. Several of those were bad. They were overheated. They were underrated. The alternator, I believe, I haven't checked it. This may be an existing problem I haven't fixed yet. The alternator goes to one of those relays and charges these up while you're moving. And then it also relies on all the other charging methods being smart enough to turn themselves off. So that relay was underrated, and it was getting hot, so it would turn itself off and back on, and a whole bunch. Actually, that was the solar relay was doing that. But we had all sorts of problems with those relays. There's a whole bunch of them there. They're not necessary. They're just added junk. So if you have a problem, those relays behind that door, this was all sheet metal, and I had it taken out and put a door there so you can get in there easily. I'm going to change these all out with the lithium in about 4 years, because they provide better power. Okay, so we're inside the unit now. I don't have any of the... it's kind of cool in here, but it's going to get hotter. So I have two solar systems. I have external plugs that aren't plugged in with on a 30 amp, and then I have a 60 amp with my 640 watts of solar on the top. So this will be showing 0 amps because it's smart enough to know I'm plugged in, so it doesn't need to send anything to the batteries. This is only what it sends to the batteries. Again, they put the remote system 3 inches or 1 inch from the other one. So what happened here is this was going through one of those relays. ZAMP says connect directly to the batteries, do not pass go, do not collect $100, and Nexus did not install it based on the instructions of ZAMP. ZAMP says that this has to go straight to the batteries. So if your solar charger is blinking, disconnect, connect, disconnect, that is just because, one, you don't have, again, the cables weren't thick enough. Two, the negative cable was hooked to the chassis. The positive cable went through a whole network of relays, some of which were overheating and automatically tripping and coming back on, tripping and coming back on. That's what was the problem with this. So these cables go directly to the batteries. That fixed that issue. My awning had a broken ground somewhere in here. So when they actually didn't put this in when I paid for it. So when I was at the factory, I told them, I'm not giving you any money until this is in there. And we started creating, calling, in the waiting room we were calling different airlines trying to get a flight out of there. And then Dave Middleton said, no, we're gonna overnight all that stuff and we're gonna fix it. So they did, but they installed it wrong. It took months to figure out what was going on there because it was really strange. It was connecting, disconnecting. But when they put that in, they broke this thing, and we had to fix that. And they fired the lady who helped us fix it. Because she was telling us the truth. So there is our battery monitoring system there. It'll come into focus in a second. There we go. So that's our battery monitoring system. It tells us exactly what it's pulling. There's nothing. You see the top left-hand corner, it disconnects because I have it's wireless. It's too far away from the sending unit. But you'll see it in a second. It'll pop back up. Anyhow, I might have to move it to be closer or run a cable to it. But there it goes. You'll see it's connecting, disconnecting. Anyhow, so this thing, so you see I'm at 13.76. That's my float, right? So it says it's discharging 11 amps, but that's not a discharge. That's just, that is actually just the, because I don't have my solar panels hooked up, that's the extra excess that the solar panels are creating that it's not measuring. So it's complicated, but it's, I put that thing in. And so let's go back here. So let me back up here. So here, so I put in this gauge down here. This is just for AC. So right now you're just reading the AC coming off of the input line. If I remove that, it would read the AC coming off of the inverter. So you guys are correct. The inverter, when it is on, is always pulling a couple watts. I mean, couple amps. I'm sorry, not watts, a couple amps, which equates to maybe 20, 30 watts, 40 watts, depending. My inverter is pretty complicated, so it has several different modes. The saver mode is not worth it's too complicated to use, so we don't use that. But so let's talk about what was going on in here. Turn on the bedroom light. So what was going on here? So so this thing, hold on here. So over here in that area where that fan, the grate is, that's a converter. So on mine, the AC output of the inverter was hooked up to the input of that converter. So we were having the power coming out of the batteries when boondocking into the inverter being converted to AC. Every time you convert AC to DC or DC to AC, you get a loss of inefficiency. And so that the power out of the batteries going to the inverter was directly connected to this converter. This converter was changing it back to DC and charging the batteries, which the batteries were removing that DC, going to the inverter, so you had a loop going on. No matter what you had, if you had nothing running, you always had 30 to 60% inefficiency because of this loop, pulling power. I estimated it was like having about several hundred watts being pulled out of the maybe 300-400 watts being pulled out of the batteries at all times. That's about the same draw as a hair dryer on the low setting. You know, that had to be broken. So we pulled these units here are all the same, I believe, for all Nexuses. The difference is from between the 50 amp units and the 30 amp units is for the 30 they only use half of this. So what we did was and then there's another transfer circuit breaker inside here that when I had them custom put on the refrigerator and the microwave to the inverter, they had another circuit breaker in there. We just moved those circuits to the right side of this. The other thing is the inverter, again, the gauges of wires were wrong. Our inverter wires actually melted. I mean, melted in a pool of plastic and smoked. They also wired the converter incorrectly. So that converter right there on the right hand side was wired absolutely incorrectly. Now what I have is I have the same converter wired correctly on it's on this circuit breaker right here, which is off. So that circuit breaker, if my inverter charger ever went bad, I can turn this on and charge it. So it's basically a backup for me. Those were the major problems that I had in this unit for electrical. So now we can have the fans on and the lights on and a bunch of, the refrigerator on, and it basically, I mean, I could basically turn this refrigerator on here, and you see it basically has a 1.2 amps that it's using. So if I turn it off, it basically is 1.1. First thing I would do is I would take a look at this converter to make sure that is not being connected directly to the AC from the inverter, that it's isolated from their inverter. So most of their inverters do not have bypass switches, do not have chargers in them like mine do. But so I would make sure that this converter is not hooked up to the output of the inverter. Ensure that's number one I would do. I would make sure that a converter in this box here is wired correctly. It's really easy. The wiring diagram is online. Just take a look at the part number and look it up. It's online. Make sure that it's wired correctly. Then I would trace. Actually, I wouldn't even trace. That's what cost me the most money, is trying to figure out what's going on. I should have just said it's bad and installed it from scratch. So installing from scratch, you know it's done the right way. There's no sense in trying to figure out what's wrong and troubleshoot, because it's just too complicated. And it's a mess under this bed. They do not have a wiring diagram. If you ask them for a wiring diagram for your coach, that's a lesson learned we had, is if you can't produce a wiring diagram, then you don't know what you're doing. So here is my inverter screen. So that's my inverter screen. It basically tells me the input voltage, the output voltage, the load, what's charging, etc. So I have it on power saver mode right now, which I told you was too complicated. This basically is okay if I'm plugged in, but because I don't want to pull any power. If you're not going to use your inverter, I would just not have it on, because it does pull power. But somebody wanted to know what the bed looked like with the slides in. You see, you can get in really easy. There's a walk around on this side. There's places to store stuff on that side, but you'll see it's right up against. These 6 cabinets are not usable, but underneath the bed there is ample room to put suitcases and stuff underneath there, right? So you could put stuff under there. This mattress we found a place to get new mattress. It's not cheap. It's about $700, but this mattress has got to go. I mean, it's brand new with the unit, but I don't know. It's pretty cheap. Better than a floor and a tent, but not much better. Anyhow, alright, so let's do how the RV was set up to begin with. I had an inverter, and then I had a transfer switch. Everyone has this transfer switch. The generator and the shore power go into this transfer switch and come out. That went into that circuit breaker box, right? Okay, and then that goes out to my AC circuits. The battery went into the inverter. In that circuit breaker box, there's a converter that charges the batteries, and what that came from this AC line, and then it went to the batteries to charge the batteries. Well, this inverter, the output of this inverter went here. So if there was no AC, this inverter took power from the batteries, put it into the breaker box, and charged the batteries. Now, whether I have any load here or not, it always did this and always powered stuff. And the batteries in the inverter was probably, as the crow flies, 25 feet away with very small gauge. Not small, but not that drop. It's the voltage drop, not the amperage rating. So what did we do? We took that inverter, we took the transfer switch, with the generator and the shore power, we took the output of that into the inverter because I have a bypass switch. We put the batteries very close to the inverter, and because I have a charger, I don't need that. I also have that excess converter, right, going to that breaker box. The inverter went to the breaker box, right? So if this breaker was on, I do this. Otherwise, it's off. This transfer switch, this inverter only sends AC to the breaker box. Only pulls from the battery when it senses there's no actual AC. So that's what we did. We moved the battery, instead of 25 feet, we moved it about 5 feet with very big cables. It may even be less than that, 5 feet. That's what we did. Now let's talk about what happens when the inverter and the batteries are far apart. So in normal operations, the battery is here. In normal operations, the battery let's just call it 12 volts. It sets 0 volts plus 12 minus 12, or plus 6 minus 6. We'll just do that. It takes that voltage, plus 6 minus 6, which is 12 volts, and what it does is it starts here. The inverter does this to the voltage, and let's say it steps up 20 steps. 1, 2, 3, 4, 5, 20. 1, 2, 3, 4. And then 20 steps below. And what it does is it will basically, this is called quantization, and it will synthesize step up the with a transformer, step up the voltage from the 6 volt. There's a step up of this, and so you'll get at the end a AC voltage of plus 120 minus 120, and it will that will be your AC voltage coming out. I don't know if it's plus 60 minus 60. I don't know. Anyhow, it's 120 the whole here, so that's probably plus 60 minus 60. Anyhow, so that is your AC coming out. So what happens when this length is too long is that when it does this step up and step down, it is starting with, let's say, 11.5 because of the voltage drop of your cable. It's starting here, not here. It's starting here. So it only can reach up a certain point. And what happens, because it can only reach up a certain point, you're going to get, and with your step-up transformer, you're going to get a sine wave that does not, because of the voltage drop. And this doesn't matter whether your cable's too long or whether you don't have enough battery power. Either one, the combination of the two are bad. And then what happen is the smart inverters, modern inverters, will detect that, hey, this is only, plus 50, minus 50, 100 volts. I'm cutting off. Boom, it'll cut itself off, because this is called a brownout, and it will ruin your appliances. So if it doesn't achieve a certain tolerance up here, it'll just shut itself off, and that's what's happening to a lot of our systems. That and this loop of power consumption, right? So that is how, I know this is messy, but hopefully the explanation and my rambling is understandable, but that is what's going on. If if you're not confident on fixing this yourself, then any electrician can wire it correctly. Don't try to trace the wires, just install it from scratch correctly. And then if you want to deinstall the excess wires, then you could trace those. But anyhow, that's how it's. I'm going to put this device in to the my inverter gets kind of hot in that bay down there, and I'll hook up a fan to this and just run this again, Drok, D-R-O-K. They sell all this stuff. This will just keep the fan running in there, and I'll just put a vent on the inside of the towards the drivetrain, and then just blow air out of there. Anyhow, hopefully that helps.